Hey guys, Dean Chase here with another geometry lesson for you. Hope everybody's doing awesome. Let's go ahead and get started with a word of prayer. Dear Heavenly Father, I want to thank you for this day you give us, Lord. I want to thank you for all you do. I pray you'll bless us with a good afternoon and just help us all just have a good day. We love you, Lord. In Jesus' name I pray, amen. All right, you guys, so today we're going to learn how to use perpendicular bisectors. This is lesson 5.2, page 303. Let's go ahead and get started. In lesson 1.3, you learned that a segment bisector intersects segments at its midpoint. A segment, ray, line, or plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. A point is equidistant from two figures if the point is the same distance from each figure. Points on the perpendicular bisector of a segment are equidistant from the segment's endpoints. So, C is equidistant from B and A because it lies on the perpendicular bisector. So, theorem 5.2, perpendicular bisector theorem. In a plane, if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. If CP is perpendicular bisector of AB, then CA equals CB. That's theorem 5.2, perpendicular bisector theorem. The converse of the perpendicular bisector theorem says, in a plane, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if DA equals DB, then D lies on the perpendicular bisector of AB. So, in the diagram, RS is the perpendicular bisector of PQ. Find PR. They want us to find this distance. Well, since we know that RS is the perpendicular bisector, we know that the distance from RQ and PQ are equal. So we could go ahead and set this equation up as equal. 8x minus 9 equals 6x. Well, we could subtract 8x from each side. Those 8x's cancel out. We're left with minus 9 equals negative 2x. If we divide by negative 2 on each side, those cancel out and we're left with 4.5 equals x. Now, that is not the question. They're not asking us to find x. They want to know what the length of PR is. So we take this and plug it back in to that equation. So 8 times 4.5 minus 9. 8 times 4.5 is going to be 36. Minus 9 is going to give us 27. So our answer is 27 units. The length of PR is 27 units. So we just set them equal in this instant. Let's keep going. In the diagram, JM is the perpendicular bisector of HK. Which lengths in the diagram are equal? Well, we know that JM bisects HK, so that makes HM equal to MK. It also makes JH equal to JK, or HJ equal to JK, KJ. It also makes HL equal to LK. Well, it doesn't make that. We know HL is congruent to LK or KL because they are labeled equal. Okay? Now they want to know, is point L on JM? And the converse of the perpendicular bisector theorem says that if these lengths are the same, then it lies on the perpendicular bisector. So the answer is yes. Okay? Example 2 of 3, I believe. Any questions? No, of course not. Sorry, that's like I'm in class. I always ask, are there any questions? Okay, so concurrency. Another thing we're going to learn today. When three or more lines, rays, or segments intersect in the same point, they are called concurrent lines, rays, or segments. The point of intersection of the lines, rays, or segments is called the point of concurrency. So, here we're going to learn about concurrency of perpendicular bisector of a triangle. The perpendicular bisector of a triangle intersects at a point that is equidistant from the vertices of that triangle. So if PD, PE, and PF are the perpendicular bisectors, then PA, PB, and PC are equal. So what they're saying is if you draw the perpendicular bisectors of a triangle, where those points intersect, they're actually equidistant from the vertices of that triangle. So each of 3 forest ranger stations is the same distance from the main office. Describe how you can find the location of the office. Well, we're going to use theorem 5.4, the concurrency of perpendicular bisectors theorem. And if we draw the perpendicular bisector of the 3 sides, those 3 lines meet at the point that is equidistant from all of the locations. Okay, so real quick, let me go ahead and draw a triangle here to kind of give you an idea of like what we're talking about. Obviously, this is going to be a rough drawing. I'd say this is about the midpoint, and that's about perpendicular. That's about the midpoint and perpendicular. And this is about the midpoint and perpendicular. So, in theory, this point should be the same distance from here as it is here as it is here. Obviously, I'm not the world's greatest drawer, but that's what we're going to do. So, draw the perpendicular bisectors of the 3 sides. Those 3 lines meet at a point, and that point is the location of the office. Okay? Hope that makes sense. Then there's just a little more information. Circumcenter. The point of concurrency of 3 perpendicular bisectors of a triangle is called the circumcenter of a triangle. The circumcenter, P, is equidistant from the 3 vertices. So P is the center of a circle that passes through all 3 vertices. So if you were to draw an acute triangle, their point of concurrency that we just learned about would be the center of that circle. Acute triangle, P is on the inside of a triangle. Okay. Then if you draw a right triangle, P is on the triangle, okay? That location would be, their point of concurrency would be on the triangle. If you draw a obtuse triangle, P is on the outside of the triangle, okay? Their point of concurrency actually meets outside of the triangle. As shown above, the location of P depends on the type of triangle. The circle with the center P is said to be circumscribed about the triangle. And that's today's whole lesson. I hope that makes sense. And you know what? You guys have a good day. See ya!